All right, let's pull back the curtain on the magic that basically runs our digital lives. We're not just going to talk about it today, we are going to lay out the actual architect's blueprint for a recommendation system from the ground up.
You know the feeling, right? You finish binging a show and just like that, bam! Netflix serves up something new that feels like it was handpicked just for you. Is it some kind of mind reading? Nope. It's just a really, really smart piece of engineering called a recommendation system. And today, we're going to design one.
So, what are we really trying to build here? Our goal is to design that recommended for you feature you see everywhere. We're creating an engine that goes way beyond just showing random videos. It's about delivering a truly personal experience for every single person who uses it. Now, every good blueprint starts with the requirements. First, what does it have to do? Well, functionally, it's got to create those personalized lists, and it needs to learn from every click and watch. But just as important is how well it does its job. This is the non-functional stuff. It has to handle millions of users, be lightning fast, and adapt, like, instantly to what you just watched. Okay, and now we get to what is, without a doubt, the single most important architectural decision we have to make. To get that speed and scale we just talked about, we absolutely have to split our system into two completely separate parts. This isn't just a good idea, it's pretty much how every major recommendation system out there is built. I want you to think of it like this. We have an offline factory and an online storefront. The factory is where all the hard work, all the heavy lifting happens. It's chewing through mountains of data, training our models. It's slow, and that's okay. It might only run once a day. But the storefront, that's what you, the user, actually see. It does zero heavy thinking. Its only job is to be incredibly fast, instantly handing you the recommendations that were already prepared back in the factory. Okay, so our factory needs a brain, right? It needs some logic to figure out what you're going to like. And it turns out there are two main recipes, or algorithms, that these systems use to make their predictions. Let's dig into how each one thinks. First up, we've got content-based filtering. The logic here is super simple. If you liked this one thing, you'll probably like other things that are similar to it. It's like a music expert who knows you're a huge fan of classic rock, so they recommend another classic rock band. The whole recommendation is based purely on the item's properties, its genre, the director, the actors involved. Now, the second approach is collaborative filtering. And this is where things get really, really clever. The logic here is totally different. It says, let's find other people who have the same taste as you, and then let's just recommend the stuff they liked. It's like having a taste twin out there, a friend with the exact same taste in books who calls you up and says, dude, you have to read this. It finds those twins among millions of users and uses their behavior to find things you'd never discover otherwise. So there we have it. Two really powerful ways of thinking. One looks at the what, the content itself. The other looks at the who, the behavior of the crowd. So, which one is better? Which one should we build into our system?
Well, which one wins? The truth is, neither of them. See, content-based is awesome if you have really unique tastes, but it can trap you in a filter bubble where you only see more of the same. Collaborative filtering is incredible for discovering surprising new things, but it has this big problem called the cold start problem. We'll get to that in a minute. So what's the takeaway? Real-world systems don't choose. They use a hybrid, a mix of both, to get the best of both worlds.
Okay, we've got our big picture architecture, and we've got the algorithms for our brain. Now we need the plumbing to connect everything together. Let's actually follow a single piece of data, like you clicking on a video, and see how it travels through our entire system. So let's trace the journey. First, your click has to be ingested or captured. Then that raw event gets put into storage, like a big data lake. From there, our offline factory grabs the data and uses it for training the models. Once the results are ready, they get loaded into our super-fast storefront database. And finally, the recommendations are served to you the instant you open the app. That's the whole cycle. For that very first step, ingestion, you need a system that can handle a massive fire hose of user clicks without breaking a sweat. That is a perfect job for a technology like Apache Kafka. It's basically the bulletproof front door for our data, making sure not a single event gets lost. And what about the heavy lifting back in our factory? Well, to process terabytes of data and train our models, we need a seriously powerful engine. The industry standard here is a framework like Apache Spark. It was built from the ground up for exactly this kind of huge-scale data processing. And finally, for our online storefront, where speed is literally everything, we need a database that can fetch a user's recommendation list in just a few milliseconds. A super fast, in-memory database like Redis is the perfect tool for the job. It's all about rapid-fire lookups.
So our system sounds pretty robust, right? But it has a classic weakness, a puzzle every architect has to solve. It's called the cold start problem, and it's all about what to do with newcomers.
So just imagine, someone literally just created an account. Our powerful collaborative filtering model is totally useless because we have zero data on their tastes. We can't find their taste twins if we don't know anything about them. So what do you put on their screen? A blank page? No way.
The simple solution is to just fall back on showing what's popular or trending across the whole site. That's a safe bet. But an even better solution? Just ask them. When they sign up, you can prompt them to pick a few genres or movies they like. That gives our system the little bit of data it needs to get the ball rolling.
But the cold start problem has another side. It's not just about new users. It's also about new items. A brand new movie just got uploaded to the platform. It has 0 views, 0 likes, nothing. Our collaborative filtering model has no clue who to show it to because no one has interacted with it yet. How does it ever get discovered?
And this is exactly why we need both algorithms in our toolbox. For a brand new item, we lean on content-based filtering. Sure, we don't have any user data for it yet, but we have its metadata. We know the genre, the actors, the director, and that's all our system needs to start showing it to the right people. Problem solved.
Wow, we have covered a ton of ground here, from the high-level architecture all the way down to specific technologies. So let's just boil it all down to the most important points, the stuff you absolutely need to remember. Think of this as your architect's cheat sheet.
All right, here are the 5 big takeaways. Number 1, offline versus online. You have to separate the slow, heavy work from the fast, user-facing delivery. 2, the 2 algorithms. You need to know when to look at the content itself versus the crowd's behavior. 3, the data pipeline. Remember the flow from Kafka to Spark to Redis? 4, speed is king, which means you have to pre-compute your recommendations. And 5, always have a plan for the cold start problem.
You know, as we wrap up, it's worth remembering why we build these incredibly complex systems in the first place. It's not just some technical challenge to predict clicks. The real goal, the art behind all the science, is to help people discover things they'll genuinely love. It's about creating those moments of delight. And that leaves us with one final, pretty important question to think about. As these recommendation engines get better and better at knowing exactly what we want, are they actually helping us discover new things and expand our horizons? Or are they just building a more comfortable, more predictable bubble around us? That's the real challenge we're all going to face as this technology gets even smarter.